Hi, so we had some issues with Delta Math and the find the area problems. So I'm going to go over a couple of them. And part of the problem was Delta Math, you don't need to use the statistics calculator. You're going to use the z-score table instead. Then another issue was when it says what percentage, we do want to write our answer as percent, but then when it said the probability or find the probability, we were supposed to enter the answer as a decimal. And I should have looked out for that. And we kept getting, students kept saying that they kept getting the wrong answer. So I just want to go over a couple of them just to make sure we know how to do them. So when Daniel goes bowling, his scores are normally distributed with a mean of 140. So I'm going to start writing down what we know. The mean is 140. And standard deviation of 12. And what percentage of the games that Daniel bowls does he score higher than 148? Okay, so I'm going to draw my normal distribution. I pretty much always sketch the information. If it's given a normal distribution, I'm going to draw a normal distribution. I'm going to put the mean in the middle, 140, and then I want to sketch what I'm trying to find. So 148. It says what percentage are higher, oops, that should be 148, are higher than 148. So that means I'm finding this area. we need to use a z-score. So I need to figure out what this z-score is. And a z-score tells me how far from the mean, how many standard deviations from the mean the value is. Okay, so we take, to get our z-score, we take the value, so 148, minus the mean, 140, divided by the standard deviation, 12. And I'm just going to go to my calculator and type this in. Okay, so I got 0.6 repeating. I'm going to round it to 2 decimal places, so 0.67. And then, so actually I'm just going to mark on here that the z-score is 0.67. And what that means is the score of 148 is 0.67 standard deviations above the mean. And the reason we need to get the z-score is then if it's a normal distribution, we can use the z-score table and figure out what percent. When we look at the table, it's actually going to give us this percent to the left. The table doesn't know that we want to the right of that score. It always gives us the percent to the left, and then we'll subtract that from 100%. So I'm going to go to z-score. If you don't have a z-score table, you could just Google a z-score table. I went to ztable.com, and then I'm going to look for 0.67. So make sure you're looking at the right table. These z-scores are negative, so I'm going to go to the next one. And these z-scores right here in this first column are positive. I'm looking for 0.6. 6 is in the tenths place, so 0.6 right here. And then in the hundredths place is 0.7. So if I go along the top, I want 0.7 in the hundredths place. So I'm going to go right here to 0.7486. So if you go to the tenths place right here, the first column has 0 in the hundredths place and then 1 in the hundredths place. This would be 0.60, 0.61. This is the z-score for 0.62, 0.63, and so on. So I'm going over to 0.67. The z-score is 0.67, so the percent, or the area under the curve, in a decimal is 0.7486. I'm going to write that down. Okay, I'm going to go back to my problem. It says what percentage, so I'm going to change this to a percent, 74.86%. But again, that's the area here, and if I want the area here, I'm going to do 100% minus 74.86%. (25.14%). Okay, I'm double checking the wording. It says percentage. I have it written as a percentage. What does it say to round to? To the nearest tenth. So it's 25.1. I don't need the 4. So I'm going to try typing that. See, I'm going to put a percent symbol. Whoops, 25.4%. 1. 25.1%. Okay. Are you sure you want to submit it? Yes. Oh, it says I got it wrong. Let's find out what's happening. 25.2. So this has been an issue because they're using this Z-score or this percentage calculator, which we're using a Z-score table. Our answers coming out slightly differently, and this is an issue that some of you were saying you had. And so I'm sorry. It's because we're using a Z-score table, which is just slightly off from this calculator that you're using. I'm hoping, though, that this is helping you. You can compare and see, oh, you're a tiny bit off. It's okay. And just go on to the next problem. So I'm still hoping that this is still giving you some good practice. Let's see, what does this say here? Oh, it's just saying what the steps are. Okay, let's try one more. Okay, I'm gonna actually, yeah, this is fine. I'm looking for one that has between. So, okay, let's try this. Okay, so the weights of oranges growing in an orchard is normally distributed with a mean weight of 6 and a standard deviation of 1. And then we want from 4 to 9 ounces. So I'm going to draw my normal distribution. 6 is in the middle, and I want from 4 to 9. And actually, it looks like we could probably use the empirical rule for this. Let's see. Let's get these z-scores. So for 4, so I'm going to take the value minus the mean is 6 divided by the standard deviation. 4 minus 6, we get negative 2. So this is exactly 2 standard deviations below the mean. And then for 9 minus 6 divided by 2. Oops, sorry, divided by 1. Standard deviation is 1, so 9 minus 6, that's 3. So this is exactly 3 standard deviations above the mean. So actually we could use empirical rule where, let's see, this is 1, 2, 3. This is actually only 2 below the mean. So this would be 5, 6, 7, 8. From 4 to 8 is 2 standard deviations away from the mean, so that's like 68%. And then we can figure out what percent to add on to there. So that's one way to do it. We're going to use z-scores instead, though, so I'm going to erase this. And then I'm going to shade in what we want. We want from 4 to 9, so this whole area. Okay, so I already have my z-scores. And then I'm going to go to the table and look up the percent, or the decimal, for a z-score of negative 2. I'm going to go up to the negative z-scores, and negative 2 is right here. I just want negative 2.0 because it's negative 2 exactly. So 0.0228. I'm going to write that down. Let's see, I lost it. 0.0228. And what that actually means, I'm going to change it to a percent because I think that's a little easier to kind of understand what this represents. That is the area to the left of 4. It's everything this way is 2.28%. And then I'm going to go to a z-score of 3, positive 3. Positive 3 is here, and it's exactly 3, so I'm just going to go to the first number, 3.0, 0.9987. Or 99.87%. And that is everything to the left of 9 is 99.87% of the weights. Let's go back to the problem. This represents the weights of oranges in an orchard. So we just want between those 2%. We don't want everything this way from less than 9. We don't want everything. We just want between 4, and 9. So we're going to subtract those 2%. 99.87% minus 2.28%. I'm just going to go to my calculator and do it. 97.59%. Okay, before I type it, I'm going to go back. It says, what's the probability? I think for Delta Math, for these ones, it actually wants it as a decimal. And it says to the nearest thousandth. So yeah, I think it wants it as a decimal. So I'm going to put, let's try 0.97, and I would round that up because it's 5.9. I'm going to round it up to 6. Again, it might be a little bit off because they're using a calculator instead of the z-score table. It's okay if you're a little bit off. Let's just see if we get it wrong. That's okay. I can go back and look at your answers and see what you put and kind of why you're getting it wrong. So let me double check. 0.976, yes. Ooh, it says it's correct. So when it says probability, let's go back to the problem. It said probability, we need to put it as a decimal. Okay, so they just drew the picture, kind of like what I just did. And again, we're not using the calculator. We're using the z-score table.